Hello everyone. In this video, we want to discuss how we can tune one PID and implement one controller, PID controller, and some transfer functions like this. So normally when we have a plant, it can be anything, for example, motor, actuator, and any kind of plants that we have the transfer function and we want to control that. So here we have this plant. And when we have this plant, we need some controller, and we should add that controller here as an input to, we have the output. So output will make a feedback here, and R here is input, and Y here is output. So for this, first we need, for example, one input. Input can be a step. Just write in the library a step and put a step signal here. Then we need one summation. Just search sum here. Then we need PID. Put here. And for plant, we need a transfer function. Just write transfer. And to observe the output, we need scope. Here is a scope. Then we can connect them like this. We can zoom. Then here, just double clicking sum. Here you can change the sign by writing here. For example, we need plus minus like this. And we need a feedback. Okay, now you can see we have the same blocks. So this is a transfer function. Here and here we can change the numerator and denominators. For example, we can have, if we put 1, 2 here, it will change to 1 divided by s plus 2. And this is a step. At second of 1, we'll have a step, and here is the output. So here we have the controller, the PID. If we just run the simulation without any modification, the PID, then here we have the output. So at second of 1, we will have the increasing in the output, and it takes around 10 seconds to more or less reach the output. So it's super slow. If we double click in the PID here, we have option for tuning. So here we have the coefficients for PID. We can change by, if you want to change that by yourself. But here we have option as a tune. If we click on the tune, then here we have a new window like this. And you can tune the output based on the response that you can see here. So for example, this dashed lines is the output without having a PID, and this line is the output by having the PID. So this is response time. You can change, make it faster like this, or make it slower. So you can see if we make it faster and faster, we'll have a peak. So it depends on what objectives you have. So we can, for example, put here. Now we don't have so much peak, and here we can more robust or more aggressive. So we can have something like this. Then if click updates block, you can see here P, I, and D is updated. And if click OK and run simulation again, you can see how it's changed. So you can see now after 4 seconds instead of 10 seconds, we reach to the 1.